My name's Ali Shaikh. I'm the Chief Product Officer for Graphiant. Before this, I was at Cisco doing the Viptela and Meraki Sd-Wan stuff for quite a while. And before that, I was doing the majority of the Viptela deployments between 2013 all the way to acquisition. I have had a lot of different hairstyles over the last several years. So if you see me looking different in a bunch of the training videos that you probably are seeing related to SD-WAN content, don't hold it against me. I was going through various phases. So what are we going to talk about? What is the Graphiant service? How does this work? So fundamentally, what we're going to start out and talk about is what is the service? Just so that we have table stakes and clear, we're all on the same page of what it is. And then we can go really deep into how does it work? And I'll just make sure I'm right on the marker so that I'm not blocking the screens. So we talked a little bit about the previous solutions that led up to what we were creating and why we were creating it. We're going to talk about like some of the fundamental pieces, right? We know what MPLS is. We know what SD-WAN is as it currently exists. MPLS is private connectivity. You get SLAs, and the provider provides it to you. You get any-to-any communication. SD-WAN is an overlay. You've got to build a tunnel. You get your control back. You've got your policy and management and everything else. But now it's on you. You have to figure out how this tunnel is going to get built, how the routing is going to happen, and how you're going to orchestrate the whole thing. If we really wanted to talk about what this solution needs to evolve into, if we're going to build a service and build a new service that combines the lessons that we've learned from both of these, it has to have the private connectivity. It has to be able to give you SLAs. It has to be able to eliminate the tunnel problems, but it shouldn't take away your agency. You should still have control over what you want to do in this infrastructure. You shouldn't have to, commission a change control and pay money for a line of config to get pushed. And you should have visibility, right? Our industry has moved to a certain point. We have certain expectations. So for us, we needed to think about what are we going to create? And how are we going to deliver this? And why are we even trying to do this? The first piece was, we know it's not just branches and data centers. There's no just hub and spoke kind of world. We've got 17 cloud regions, 8 colo locations, 5 different colo providers. I've got remote workers. I've got all this IoT coming online. I've got a multitude of business partners that want different kinds of connectivity. How do I make it all work together? Do I go to the service provider and commission a network and then go back to what I was paying from an MPLS level? I don't want to do that. Do I try and build a SD-WAN based overlay? And that is going to take an astronomical amount of time to figure out how I'm going to build a tunnel from each of these locations, then maybe do dual tunnels or maybe 4 tunnels. And if it's going to go to 17 data centers, that's 17 times 2. If I have 2 more circuits, well, that's times 2 more. If I put in LTE, well, that's another one. If I put 5G, well, that's another one. How many tunnels do I have now? What is the next hop resolution? What is my path calculation? What SLAs am I going to program on this? The level of complexity that our current models have aren't designed for this kind of world that we're starting to enter, or at least the boss is telling us, go build a network that does all these things. How do you get there? This is where for us the idea was, well, we have to build a service. We have to have provisioned and built out a network that lets you achieve this, but this network needs to be programmable by the users themselves from the source. How will we get there? Those are the things we're going to talk a little bit more in detail about. But this is the fundamental premise here. We want to take the lesson of the MPLS, that private connectivity, peer-to-peer, and guarantees, but make sure the user has agency in the right way without inheriting all of the complexity that comes with building that kind of infrastructure. I can tell you an example, having done a bunch of different SD-WAN deployments. We used to run into this challenge constantly, especially in the large enterprises, where they would say, 2 data centers wasn't the norm anymore. 4+ data centers is definitely the norm. Multiple head ends, multiple circuits per head end. multiple protocols, Anycast networking, a whole bunch of things running. And now you're going to layer on AWS, and now you're going to layer on Azure and GCP. Which traffic goes where? Okay, let's maybe go to Equinix and figure that out. And we're going to buy some really expensive boxes and put it in Equinix. And it's like, well, that didn't really solve the problem. It now just compounded the problem because I couldn't take away my data centers right out of the gates. And now I need to add all of these Equinix regions to my data center mesh, to my cloud mesh. This is where, for a time, we started looking at cloud on-ramps and trying to do layer 2 connections and a bunch of different things. But it was still, from a networking standpoint, it was still the problem of, well, a VLAN is a VLAN. It doesn't matter where I drop a VLAN, it's still just a VLAN. It's a layer 2 connection. And I know everything that comes with trying to just do it over layer 2. A wide area network built entirely on layer 2, that's generally a bad idea. So now it becomes a question of, all right, so I'm struggling already. And this was, I had the misfortune of being on constant escalation calls because at a certain point, the customer would try to push the solution to a point where it wasn't designed for. And now I've just got tunnels upon tunnels upon tunnels and a policy landscape that is just getting harder to navigate. And when we talk about the policy piece, we aren't even really talking about the application at this point. We're just talking about how does the IPsec get set up? How does the BGP get set up with all of these different endpoints? Application comes later. Right now, I'm just first figuring out what the network looks like. So this is where, for us, we spent the last 2 years thinking about this service has to be built a certain way. We don't want users to have to do this. They shouldn't have to spend that time designing this landscape of IPsec and BGP and all these other things. They should be able to go straight to, this is the application, this is what I want for it, and Graphiant or somebody, you're on the hook to make sure that I get an SLA for that application. That's what I want. So what we started to think about was, what will we bring to the customer? The how comes right after this. So what will we give to the end user? What do you get? This is where we started to think about, well, in pretty much our principle is every endpoint is an edge, whether it's the cloud, whether it's the data center, it's the branch, whatever it is at the edge of the wide area network. So everything is the edge. The edge needs guaranteed delivery, just like they used to get with MPLS VPNs, but they want to use the internet, they want high bandwidth. How do you give an SLA there? But you want to be able to have an SLA. They don't want to build a network. The network should already exist. They should simply subscribe to the network. So the idea being where instead of having to design the policy constructs for your overlay before you start migrating your sites, your site shows up and you subscribe to the kind of connectivity network you want. This came from the idea around, if AWS and Azure and GCP could do that to the compute landscape, why couldn't we do that to the network landscape? We no longer think about the fact that AWS is, strictly speaking, huge farms of compute. Those are physical locations with a whole bunch of data center compute, but we don't even think about it that way. We just call it the cloud and just subscribe and buy however much compute we feel like. Mentally thinking of enterprise connectivity in that way is the transition we wanted. How do we go to that model? So you start subscribing to the private network landscape rather than designing, building, or commissioning it. And then, of course, technology just for the sake of technology is never a good idea. There should be a tangible benefit to having to do this. And especially, I mean, with what's happening with the economy, the first question that we tend to get asked is, great, you've built something cool, sounds great. How much more does this cost? And will this cost me an arm and a leg to do? So this is where, how do we make sure that as we build this, there are cost efficiencies that get passed to the customer? So the technology that we build should inherently give us cost savings that can go directly to the customer. So we'll see that in just a minute. Now, networking being network, is there a box? And what kind of box is it? And how many ports does it have? And who do I buy it from? And does it have ASICs and line cards and all these other things?
Who controls it?
Who controls the box?
Yeah.
This is where, for us, it was, again, if we really are committed to the path of this being programmatic, then this can't be a proprietary box. And this can't be custom hardware. This is where we've initially, Lanner is the most furthest along in terms of partnership with Dell, HP, everything else is in the works. But the idea being, if it's x86, you should be able to run it. Now, who controls the box, right? And there's the legal language around it, and then there's the engineering language around it. From an engineer standpoint, the engineer wants to have control over the box, because whatever the policy is, whatever the configs are, whatever the troubleshooting capabilities, the customer engineer should have access to it. So as a network operator myself, I would say, no, I don't want to give away control to the box. I would like to have agency over being able to programmatically interact with it, or even through a dashboard, whatever it might be, but I have control over it. But contractually, becomes a question from a business standpoint, do I want to buy boxes? Do I want to lease boxes? Do I want to have a partner or a provider provide that as a service? Those are financial and contractual options that open up. But from an engineer standpoint, again, agency is very important to us, that the person who has to actually run the network doesn't lose control. So you always can see it, you can interact with it, and even though it's a service, again, like thinking around the way when you think about AWS, the server inside AWS's data center, AWS owns it, but you control the compute and you control how you're using the compute inside AWS. Here, the idea being, this is a network already built, delivered to you as a service, but you have control over it. So what are the form factors that we're looking at? Enterprise being enterprise, there's a billion+ pieces of routing equipment out there in the world in various degrees of end of life, in varying degrees of code versions and warranty levels on it. So the question becomes, some people will still need appliances, so they can get those through us, through partners, through providers, because it's not custom hardware. This could literally run on any server. This could run in virtual machine form factor, because that's a given. We now expect that kind of capability. But where does this go next? And when we get into the protocol layer, and when we start talking about how all this works, you're going to see that the idea here is very soon we're talking about containers. Very soon we're talking about kernel modules, where the ability to access this network can directly be at the host level, because there is a new protocol in play that allows the host itself to say, this is the encapsulation I want, this is the metadata I'm putting in the packet header, do this for me, network. At this stage, I'm gonna be very real, this is what is in production now. The containers and the Linux modules, those are in our roadmap. We have some partners that we're working with around how does that come into market and how we consume that.
This is a lot of words that sounds like you're summarizing white box.
So, I appreciate you saying that.
The opposite of summarization here.
Yeah.
So, the difference between, and why I'm not strictly calling it white box or UCPE right out of the gates. Why am I not saying that? The reason being, when you think pure white box model, who's orchestrating the software on it has always been kind of fuzzy. Are you loading a hypervisor on it? Are you getting, AT&T's orchestration system, Cisco's orchestration? Who's orchestrating that piece? Could it be white box? Yes, but it doesn't have to be. It could be bare metal. You could essentially take an appliance and overwrite the software package, and it runs as part of the Graphiant service. So this is why I'm very careful about not necessarily saying white box, but maybe if UCPE sounds better, maybe. I don't know. That also has mixed connotations around what UCPE means. Then when you look at some of the platform types that the likes of Lanner, Dell, HP have made. There are a lot of now lines of hardware that they've made that are accessible from a bare metal standpoint that you can program and load up your software with, but they've been tuned for networking purposes. That is, they have specific port density, they have specific tamper-proof module chips, they have specific capabilities that they've loaded in, like native LTE or 5G support. So there's certain flavors to it. And that's why I don't know if there's a good word in the industry to say I could take any piece of metal and load software on it for my purposes.
I thought that was white box.
I thought so too, but then when you see that in practice, right, it's always been like, well, there's a layer and another layer on top. Is it running straight on the metal or not? That's why I would say,
But
if you,
but does it really matter? I mean, it's whatever service you guys are selling running on bare metal on a white box chassis.
yes, that is a better description. I would prefer to use that. The reason I got into trouble a few times before, if I would just say white box, is because the customer was like, well, what's the orchestration shim on it? Is this Flexware or something else?
Okay.
And that's when I was just like, well, I don't want to get into that conversation around, is there a shim that is someone that you're paying somebody else for?
Yeah. So how are you guys expecting to deal with customers that really don't want the split support model? Sorry, it's early still. As a customer of, say, Nutanix, we were early on partnered with Dell for our Nutanix hardware, and that support model is a living nightmare because I have to go over here for hardware support, and well, maybe it's not all hardware that's the problem. Maybe it's something the firmware in between, and well, now I got to get the hardware provider to call Nutanix because I bought the hardware with Nutanix on it, so Nutanix or Dell has to do the support. And it's not a situation that a lot of enterprise customers are going to want to deal with.
I agree, and this is why the white box term gets me into trouble, is because okay, the box is someone else's, the orchestrator someone else's, and the software is someone else's. For us here, this is where we needed to think about, okay, this is the problem that we're going to run into. How do we tackle it? There's two ways to go about this. One, and this is where our lead motion in the enterprise space, is partner. Because if the partner is providing the whole thing as a service, then they're the ones providing the support for the hardware, software service, everything else for the enterprise. So they're the front end. And it becomes their kind of headache to deal with that piece on behalf of the customer. But they're already set up for it, and they already do that for a lot of enterprises. So we're seeing a lot of, is it a WWT? Is it a Presidio? Is it a various entities of that nature? Could they handle that for them? So we see a lot of interest from that. But that's not to say that's the only way. We have some customers who will say, you, Graphiant, do the whole thing for us.
Yeah. Yes.
And that is the model we provide, because the whole idea of it being as a service has to be the whole thing as a service.
Yeah, there's nothing stopping Graphiant from spray painting a white box their own color.
Well, I think the important thing here, though, is that when you buy hardware from one vendor and the software running it from a second vendor, what will inevitably happen is they're both going to say it's your problem. And then in my mind, since you're the software vendor is really the one that has to step up and say, it's always my problem because my software is not working, and I will help you determine how to communicate to the hardware vendor
Exactly.
that they have a hardware problem. However, it is the rare software company that's going to do that. And if you don't do that, I predict you'll fail.
Agreed 100%. Agreed 100%. And from my perspective, that's the difference between white box and what we are looking at here with this hardware edge. It's bare metal. As Ali said, the first version is a Lanner version. It's a Lanner 1515B. It's bare metal. We install our software straight over the top of it, and then we own the troubleshooting and all of that until it's determined it's a bad NIC, it's a bad power supply, it's that kind of thing.
Right.
And then it's the hardware vendor.
But my financial people are going to insist, because we love capital expense,
You have to buy it.
I buy that hardware
So-
and that I capitalize it and own it.
So and we understand that. Believe it or not, I have a degree in accounting. We understand that 100%. So that's why we are partnering with, and like I said, Lanner is the first version. We won't sell you a Lanner box. But if you get a service from us with the Edge included, it's that Lanner box. And I'm not even spray painting it. I'm not spray painting. I'm not putting a logo on it. It is a Lanner box when you get it. Okay. So then I support all of it, but I'm not going to sell it to you. So capitalizing it, your finance team is not going to be able to capitalize it.
Right. And my previous finance team that wanted to lease it, they can go lease it.
They can go lease it.
Exactly.
If they want to capitalize it, then you would buy those exact same Lanner boxes. Remember, not spray painted. Those exact same Lanner boxes through WWT or your VAR of choice. Your VAR of choice. You would buy those Lanner boxes. They would get deployed. We install software over the top of them. I own that troubleshooting.
Yeah. And this is an important distinction that, as you were describing it, is why we wouldn't call ourselves a software vendor.
Right.
Because we didn't sell you the software. We're giving you a service, which means we have to own the handling of all of that part. You didn't pay for the software. You're not contractually bound to the software. You're buying the service from us. So we are on the hook to provide the service down to the box.
So in that situation, I'm paying you for the service.
Yes.
Do I have one phone number to call?
Yes.
It doesn't matter if it's the hardware.
You have one phone number to call for support and troubleshooting.
Okay.
If I'm providing you the hardware as part of that service, it's soup to nuts.
Okay.
Through that hardware. If you have hardware through that you've purchased because your finance team wants to capitalize it and depreciate it, then you're still calling me and I'm troubleshooting. But when we identify that it is a hardware problem, sorry, Lanner, if we identify it's a hardware problem, then you would go to either your manufacturer of the hardware or your partner.
And I can, the way that you're explaining it, and it sounds like the way that you've built it helps me understand why you don't like using the term white box.
Exactly.
Because other companies could, in theory, use this exact same, the exact same hardware that you're using
100%.
and take the white box approach.
Exactly.
But you're making that disappear as part of your service.
Yes.
Correct.
Okay.
And
You can buy those
Zach
Lanner
is gonna
boxes
be
on
the
Amazon.
conference call bridge when I open the thing with the hardware to help me
Yes.
explain why it's a hardware
Yes.
problem so that
It-
it don't get
I-
bounced around to infinity.
Ideally, it would be, you would say, you guys go tell them what the problem is. I'm just gonna sit here and wait for you to tell me when it's gonna
Well, I
get
need to
fixed.
be there because the contract's with me.
Yeah.
Yes.
Yeah.
You need to be there present to see it get done.
It all
Yeah.
depends on who you buy it from.
No, it doesn't. They're all terrible.
No, but if you buy the hardware from Graphiant, all you have to do is call them. It's when you want to buy your own hardware and throw their stuff on it that
But we're
Yeah.
we're not going to sell you hardware. We're not going to sell you hardware though.
You're going to sell a service.
Sell a service.
And it's going to come with hardware.
Yes.
but yeah, but
One
we
of
still
two
call
You still call us.
yeah.
Yes. The other comment I'm going to make, the spray painted box. There is one
In the world.
Graphiant Edge in the world painted. We had the blue and orange discussion earlier. Painted blue and orange with Graphiant logos on it. There is one in existence, and there will only ever be one in existence. It is framed and in college, our CEO's office. It was until yesterday when we presented it to him as part of the launch.
Wait, you mean until I call MBX over in Illinois and have them?
They paint it for you.
Yeah.
Sure.
Yeah.
Yeah.
I do want to give you guys one piece of feedback, and I know you guys have been told this before, and I fully understand this is literally public day 2 for you. But please go hire a TME, like immediately.
Yeah.
I love you guys. Like I love everything I'm hearing so far, but getting that communication very clear to the enterprise is
Yeah.
going to be very important.
Yeah.
Yeah.
And I don't want them to have to be as confused as we were here the first 30 minutes of
yeah.
this conversation.
Fair enough.
Yeah, and kind of on that point right there, 2 things. Don't be afraid to come up with a name for it. Like try and figure out what that name is, even if it's a dumb name and it's like, oh, this is kind of cheesy, but at least you can coin it, you can make it your own, and then hopefully make it a standard conversation piece. And then 2, don't be afraid to ship a sticker with it. So even if somebody wants to put a sticker on it and identify it as yours, or I'll just put it on my laptop.
I guess maybe it's time to come up with gray box.
Gray box.
I think that there was a bright box term.
Yeah, coin
While ago, but-
before Gartner does.
That's a quick way to get in the magic quadrant, though.
There you go. I'll hand it back to you. Sorry.
And
Always
actually, I want to expand a little bit on my statement there. So what we've taken, at least what I've taken from this so far, is we're looking at an SD-WAN, SSE, DCI plus Cloud Fabric solution, all kind of pressed in a single box.
In a network service, and we'll talk about how all those things get delivered to the box that is at the site.
Yeah, because the connectivity from wherever your core lives to this site location is going to be very interesting.
Yes, absolutely.
Oh, we forgot Megaport. That was Steve's comment.
So where do we want this to go? And this goes into the exact point that we were talking about, which is if that's the edge that gets to a particular endpoint in the customer's environment, we're talking about the software-defined cloud interconnects, the SASE connections, the SSEs, the this, that, or the other. The way we describe that is you want to be able to connect to the services of your choice using this core service that we're going to talk about, how the control plane, data plane, all these kinds of things work in this environment. The idea being, if I want to subscribe to an SSE service, I'm not trying to figure out which Zen hub I'm going to tunnel into. I'm going to subscribe to the Zscaler connection as part of this service. If I'm using sky-high security, I'm not trying to figure out how this tunneling is going to work. If I want to use cloud interconnections, I don't have to figure out which port I'm going to buy and which VLAN is going to land where, because from the edge standpoint all the way to the cloud, everything is handled as part of the service. So the idea being, can you program this?
Am I way off in thinking that this almost sounds like you're virtualizing the internet exchange?
We are. Now, the protocol is how we're going to do it, but it is the idea of the internet has to be, in a way, rewritten if we're going to program the internet on the fly for the things we want to access and the way we want to access them. So the idea, and this is now we're going to jump into control plane right after this, is the idea being fundamentally, how do we eliminate the fact that we keep building tunnels and overlays to access things? Can we programmatically interact with the internet to get access to the services? How do we do that? Those services can take lots of different form factors. One of the most popular one that we will talk about from a use case standpoint is SSE. But the idea being, how do we eliminate that problem from the enterprise? And as someone who has configured way too many IPsec connections from SD-WAN devices going into Zscaler, it is not pleasant. So that, in a way, is the motivation that I had to come to do this. So we've kind of come to an understanding of it's a service. There's an idea of what this service needs to do and how it will get to your physical site. How is this going to work? How are we doing something that's different that allows us to do this? So we need to think about, and this will be a little bit interesting as we get into some discussion here, especially in the networking space. We know there's the control plane element of setting up the information of the paths, the routing information, the data plane, and then the encryption space. And typically in networking, we would kind of associate all of those in almost a pairwise relationship historically. If I talk about an IKE-based IPsec VPN. So I'm going to set up a relationship. If I think about the sequence of events in say, classical DMVPN. I'm going to set up a GRE connection to run BGP, to run IKE, to run IPsec, to hopefully not have to, but run NHRP or whatever. The idea there being you're setting up pairwise control and data plane relationships. And then you had the encryption layer on top of it. If we need to build a service, we need to decouple them, all three of them. We need to make sure that the control plane and the data plane are not on the same path. And then within the data plane itself, we need to think about encryption, decryption differently, where if we classically think about how tunnels get set up, you have an encryption, decryption event at each hop. And that is a fundamental problem if we're going to try and build this kind of infrastructure. So how do we solve that piece? That is the root of what our protocol setup is going to look like. So what does the control plane do? What does the data plane do? And how do we handle encryption, decryption in this environment? This is where we're also doing something that is a little bit unique and why we're doing it that way. When we talk about privacy here in this solution, we're talking about end-to-end encryption with no decryption in transit. And this is where the tunneling aspect is different, where if you think about an Sd-Wan overlay, you are going to have to decrypt no matter what intermediate point you set up. Whatever that solution looks like, whichever vendor you go with, there is an encrypt, decrypt, land in a VRF, route lookup, re-encrypt, go somewhere else. And as many chains you create, there is that constant event that happens. If we use that same principle that Sd-Wan had done, we will not be able to scale this. It would not be possible to do this, and it would create all kinds of compliance issues, because now that traffic is transiting to this infrastructure, if you decrypt someone else's data in your infrastructure, you take on the liability of what that means. So here, we needed to make sure that as we construct this tunnel, we cannot break the encryption in transit. So the encryption key and that control remains with the end user. Us, as the service entity, cannot see or open up anyone's data. Now, this immediately will plant in your mind the question of, well, you can't really do full transit security services if you're not looking at anyone's data. So in that way, I think fundamentally, we wouldn't strictly fall into the category of what may be termed as SASE, where you try and put networking and security all together. We are not trying to look at anyone's data in transit. We're not trying to make it pass through a series of firewalls or anything of the sort, open up the packet, inspect everything, and then route lookup, encrypt, and send it again. Because there may be too many intermediate paths. We can't do that. This is where our relationship with the SSCs will become a little bit interesting when we talk about that, but this is where we are fundamentally different from any SD-WAN solution and any even middle mile solution that you will see. So whether you talk about the Megaports, the Packet Fabrics, the Katos, the Ariakas, whoever you talk about, you can verify quite easily that there is a decryption event that happens because they have to terminate the tunnel, they have to do a route lookup, they have to figure out where it's going to go, layer on whatever services they're doing, and then re-encrypt and send it off. This is going to be the basis of how we are going to be able to do things differently. So this is a fairly generic diagram, but it kind of gives you the first lay of the land of how this is going to work. The edge that gets deployed at the customer premise is going to establish a control relationship to a cloud delivered portal through which you give the management, the config, the APIs, and the interactability to the endpoint that you want. But the actual data plane is going to be delivered through what is this stateless core. And we're going to talk about how this is stateless because we just described the fact that there can be no customer information in this core. The biggest difference here, if I compare this to, say, MPLS VPNs, is we're trying to eliminate the PE problem, which is you shouldn't have to configure VRFs and maintain large amounts of routing state in this core environment. If I think about the SD-WAN equivalent, I'm trying to eliminate the amount of tunnels, the tunnel overhead, and all of that that comes with current SD-WAN deployment models. So the idea being this core has to be fundamentally stateless. No customer config, no customer VRFs, no customer routes, nothing is in this. This is a pure packet forwarding space. So what do we do? This is where, from a protocol standpoint, and this is one of the first questions that immediately gets asked, did you do something proprietary? And is this a locked-in protocol or something of the sort? And we know that that's never a good thing to do. So for us, it was, well, what's the protocol that we know runs the internet? BGP. Is BGP extendable? Of course it is. Can we create extensions for BGP? Of course we can. But can I get them ratified by IETF in a meaningful amount of time? We know the answer to that one. So here it was the idea of, let's take the principles, knowing that at a certain point, we want it to go to the IETF, to get ratified, to be adopted. But we know that it's going to take time. And more than anything else, we need this to get deployed, have customer adoption, see people use it before it goes into the standards process. But this is where we looked at, let's look at BGP and how it can be extended. What are the capabilities we can introduce to make this possible? This is where then we also need to think about, well, the classical address families don't necessarily have all the extensions that we are looking to add. So especially when I want to add things of the nature of, whether it's segment information and segment information beyond just what segment routing can do around application information, application characteristics, and things of that nature that I want to be able to add in the routing protocol itself. So there are some extensions that we've built ourselves that allow us to propagate additional information. Now, the main goal of this will be to now take a combination of this protocol creation that we've done to then apply these precepts and leverage MPLS VPN label switching techniques in the core. So can we convert all this information and package this with metadata information, with labels, so that for traffic forwarding purposes, we're purely label switching. We're not having to do the full route lookup, VRF lookup, and decryption event in transit. So this allows us to set up the enterprise for the end user to see their sites get deployed, to have the routing information, their routing information, the way they're already accustomed to seeing it with the route tables and whatnot, but not having to think about how it gets built over the wide area. Because migrating a user is automatically going to become the question. Like if you created something new, how does this enter a brownfield environment? How can you do a migration if this is totally new? So we needed to have that intermediate point. So how do we evolve the SD-WAN boundary point, that WAN edge space, where when an edge lands at a branch location, if I cut over just that switch over from device 1 to device 2, or if I just loaded a new software package, I shouldn't have to rewrite my whole network. This should give me that migration path with what I have familiar, and then transition me for the wide area connectivity into something new. This is where then it has to translate into, which is, if I've set up the edges and they're connected to this cloud delivered portal, and from here I can define my policies and configurations as I would for my branch, the main thing becomes, how do I get access to this core that is being delivered by Graphiant as part of this service? And how does it actually move my traffic from point A to point B? If I think about it architecturally, the thing that I would closely, most analogous to this would be a backbone of P routers and not PE routes. So rather than landing a whole bunch of customer config on it, there's only a label switching environment here. So the controllers, the off-path controllers, are able to provide devices metadata-based information. The edges subscribe to the core network, and the core network is able to look at just the labels that are set in the headers of the packets and move traffic as necessary. Now, this is where, when we think about the breakdown in an MPLS world of CPE, PE, P, we're kind of describing a world where we're collapsing a lot of the PE function directly into the CPE so that the core doesn't have the overhead of the PE routers, which is all the VRF state, all the routing state that typically is in an MPLS PE router. This means the edge is becoming a little bit smarter because it has to know from a controller standpoint what all it can do, and then set the metadata in the header, and the core, this transit, becomes completely dumb, and that it only looks at the label and moves traffic based on that.
What's in that metadata?
This is where, in the metadata space, there's a number of extendable attributes that can go in there. Right now, you can specify loss, latency, jitter, SLA characteristics. You can specify extranet connectivity. You can specify what kind of NAT translation events you would like that kind of traffic to have, so that as this is brokered between one site and another site, the sites know what to do once the data arrives. But as it's transiting, if the core doesn't have to do anything to it, then it doesn't do anything to it.
This is kind of like spine and leaf type thing, right? The spines don't really care. They just ship packets out.
They just ship packets.
Right?
Exactly. Because the idea, a lot of people were like, well, are you trying to turn the whole internet into a SAN or like a storage fabric in a way?
Edge core edge. Yeah.
Love that.
Because this is where, if you think about why we're doing it this way, everybody else is putting a lot of state in the middle, a lot of information in the transit space. So whether you think about any kind of other solution, whether you're layering in a whole bunch of firewalls sequentially, or load balancers, or routers, or VLANs, or cross connects, or everything else, there's been a tendency in the industry right now to try and put everything in the middle somewhere, so that everything from the edge goes to a point, to a POP that now has to have a whole bunch of compute because there are a whole bunch of services in serial that you have to pass through before it goes anywhere else.
Where are the cores at?
The cores are, when we think about where they are, Equinix, CoreSite, Digital Realty, your usual suspects. Now, everyone in the beginning always would ask me, it was like, why didn't you go into the cloud itself? Like, why didn't you use a cloud backbone or go straight into the cloud? Especially if you are not, having to layer on so much resource to actually deliver this. And the main reason is egress fees. The main problem ends up being cost, because even though I can optimize a whole bunch of things, I have no control over the cloud backbone cost. I have no agency over that. And I pay that on a per gigabit rather than on a per gigabit per second. Whereas in the transit space, I can actually get a good amount of capacity at a very, very predictable price point and deliver that service. The advantage I have of being in Equinix, in CoreSite, in Digital Realty is because I'm not having to need tens of racks or thousands of racks. I'm not looking at megawatts of power draw because I'm layering all these services in these POPs. My footprint in a colo, in a POP, is very small because my device, my transit device, doesn't contain any state, and it is able to multiplex a multitude of customers. So
Anything outside the United States?
Right now, at this point in time, we're primarily US only. Next year is when we're expanding into Europe and Asia Pacific. So our pilots and customer engagements initially have been US only.
For larger customers that are geographically diverse, not just within the US, but eventually when you do start going outside to EMEA or wherever, can we host multiple cores and connect them together?
Absolutely. And now this is where things become very interesting for us. And this is where we're doing an interesting project with Equinix. Because our footprint is so small, and because we don't need huge amounts of compute, anywhere Equinix or Digital Realty or any of the different entities provide bare metal as a service or different kinds of compute footprint, we can expand into there very quickly because our software isn't coming with a whole bunch of customer config. This also gives us the flexibility to go into a bunch of data center locations and deploy multitudes of cores, even if they're like 2-3 milliseconds apart. So someone says, you have this one location in Boston that's great, but Boston's not good enough. I also want it in Foxborough. Okay, sure. Because as long as there is a facility, we can easily bring it into our service. What this allows us to do from a service delivery standpoint, from a contractual standpoint, is that a customer, we can contractually tell them, contract plus 90 days, any location can be serviced. And that is because I'm not looking massive amounts of lead time. Now, capacity planning becomes my whole life, is how much bandwidth are certain customers asking for in certain regions? How much of that can be provisioned as quickly as possible? How much is there on ECX Fabric? How much is there on Zayo, Hurricane Electric, Telia, AT&T, Verizon?
That was going to be my next question: is are you using public or private fabrics to interconnect those cores?
And we're looking at all of them.
Okay.
Because this keeps coming back to that idea, right? Where all of these now I can multiplex a lot easier because each of these has its own particular tag. And I can decide, depending on what quality you want, what SLA you want, which one you take without having to re-provision the whole network, without having to reconfigure a particular customer each time they want to switch something. Or if there is a outage event, I'm not looking at a global IGP convergence issue. So this becomes our approach to tackling that. I can plug in all of the connectivity that is available in a facility. And yes, that will be my lead time around who can give me a 10 gig handoff versus a 100 gig handoff versus a 400 gig handoff, and then figure out how much capacity projection I have in terms of consumers consuming it.
You can guarantee these QoS settings across.
Yes.
Even though your service you got to make sure your service, your underlay does that, right?
Exactly. And this is where, when you have the private wavelengths that are reserved for you, you have a different degree of reliability. If you have the dark fiber, different degree. If it's the, if it's the public. So this is where it becomes if you, the user, say, this traffic is best effort, well, it could go anywhere. But if you say, I wanted this particular service from Graphiant, where Graphiant says, this is the thing that we provide you between these locations that is on this kind of wavelength, that is this private, this is the SLA level, and that traffic will get tagged and routed over our service based on that tag. So it's almost, we know no one really enjoys QoS.
Understatement of the year.
But we can't seem to get away from it. And this became the aspect around, if someone says, no, I need it to be this way. Okay. But this also led us to think, well, all right, yeah, QoS was like congestion control and prioritization and things of that nature, but and this is, I know, a tall order, could QoS be redeemed somehow? And it became the question of, well, why is QoS just restricted to quality, congestion control, and prioritization? Could QoS eventually be extended to, well, this is the HIPAA lane, this is the PCI lane, this is the SOC 2 lane, this is FedRAMP, FIPS, whatever. Could it be extended? Could it go beyond? Could we say this is low latency traffic, this is non-low latency traffic, rather than just putting it into a bucket and hoping that it's going to be honored all the way through? Now, I know that's a bold statement and hopeful optimism, I guess. But the idea being, why can't it be extended? If we have the infrastructure and can be programmatically interacted with, can I put it into my data plane, into my headers that say, yes, this goes into EFQ, is low latency, fastest prioritization, but also I wanted to only take dark fiber paths, or I only wanted to use, US sanctioned paths. Don't go into countries that the US government doesn't want you to go into, or pass through a cable that may touch a country that the US government doesn't feel very comfortable with. Why can't that be done? So this is where we are thinking about that piece.
Please tell me you have my favorite Viptela feature, last resort.
We do. We do. That opened up another bunch of things for us was, well, last resort is about to get a whole bunch more fun between 4G, 5G, and which radios and which CBRS and which Open RAN, whole can of worms there. So your favorite feature is about to get a whole bunch more extendability because of what's happening. Now, a lot of the times this will raise the question of, this is a big undertaking. You're going into a whole bunch of POPs, connecting into a whole bunch of carriers. You're basically, in a way, a carrier of sorts or a service provider, but you're also providing the software and you're providing the hardware, but you're also not really managing it in the way that a typical telco would. There's no change controls with us in that way because we're not having to reconfigure each intermediate device. You are simply putting it into the headers and you're getting certain SLAs. What does this mean for you as Graphiant? Like, why are you able to even do this? And why would anyone even bother? And this is where, when we started to look at bandwidth, and this comes back to why I wasn't a fan of doing this inside the cloud, was cost. And some of the numbers are kind of ridiculous. And it was the compute, like deploying a Viptela V-Edge or even a Cisco Catalyst, what is it now? Catalyst 8000V? Deploying that, like deploying the virtual machine is not a problem. Expanding the compute or storage on it, not a problem. But the more traffic that transits, the more traffic that egresses, that cost just goes up and up and up and just absurd levels. We saw with a particular customer that was doing a pilot that because of COVID, they moved everything onto the Amazon backbone. And yeah, you can exactly imagine what happened to their bill. This is why, for us, we know workloads, not everything will move to the cloud. As much as people would like to believe that, that will never happen. Edge compute is there, IoTs are there, people still have data centers, and there's still so many applications that are still .NET written from whenever. I think there's still in the retail space, people still have what, the Windows 95 based scanners?
Oh, welcome to healthcare.
And this is why it was, we need to move to a more predictable model. And if the carriers won't do it, then from a software standpoint, why can't we commoditize the internet? And if the internet was virtualized, you could get those kinds of cost flexibilities because we know what the fiber costs between one point to another point. We know what the wavelength reservations are. We know like the business models in a way of how Equinix has achieved their fabric or how Megaport or Packet Fabric or anybody else does it. You know what their connectivity points are. You know what the fiber is that is laid in the ground. And there is a fixed rate for the speed that you get rather than per gigabit pricing egressing from the cloud. The biggest trouble with all of that is that the enterprise doesn't have the ability to directly interact and program that entire landscape for their own uses. It is not so straightforward. I mean, it's very easy to buy a port on Megaport or Packet Fabric and get a layer 2 connection, but then everything else is still remaining to be done. Who's going to set it up? Are you using it as an on-ramp? Is it landing in your data center? What's the BGP? What's the multipathing? Which ASs go which way? That still has to get done. And trying to deploy a VNF or another, unfortunately in our case, historically what we were doing wasn't great, was deploying like a Viptela appliance or a virtual appliance inside those environments. Like you're just adding overhead. Why am I having to land a VM inside this intermediate point just so that I can use a layer 2 connection going somewhere else? Why do I have to do the layer 2 piece at all? Why can't this entire middle space be programmatically interacted directly from the edge point itself? I mean, we no longer, when we use Google Maps as an example, we don't really think about the fact that there is But Google is facilitating all the information between all the GPS satellites and coordinating all that information. Just plug in the destination you want to get to, and they figure it out. There was a time when we had the physical maps and we'd be like, okay, we're going to go from here to here, then from here to here, then from here to here. Why should we have to do that in networking? Fundamentally, why should we have to do that in networking? And this is where, for us, during the Sd-Wan experience in particular, by 2018, 2019, it was getting to a point where, with almost all the customers, even when we would do the cloud on-ramps, it was, okay, there's a 2 VLAN limit inside a bunch of these facilities that can land on a VM inside this space. Okay, how many VMs do I need? Well, the VM itself also has a 500 tunnel limit. Okay, so how many sites can I land on that one VM? Well, I need 2 VMs with a 500 tunnel limit with X number of VRFs and prefixes it can handle, and X number of VXCs or cross connects that I can land on that virtual machine. What is the design effort to build an enterprise network just to use a cross connect in one region? Now I multiply that with the number of regions I want this in. What is the overhead to do that? Now I know there's huge amount of business value in having consulting service just around that. You could do a lot, but it seems wrong. And that's where for us it was, okay, could we program this using the off-path controller, remove the state from the transit, so that from the edges standpoint, it is able to communicate with the controller and say, what is the metadata tag that I need to use so that all of this thing in the transit, it forces my traffic to go into this particular Equinix location, takes this dark fiber path, gets to this other Equinix location, and uses that to go over some other AT&T or Verizon connection into the edge on the far side. Or if I'm going into the cloud, directly handle that and land me into the VPC or the TGW that I specify using my APIs. Don't make me build the tunnel or the route table to do that in transit.
Yeah, Lee, can you go back one slide?
Sure.
So I want to just talk about this really quick. So before anybody looks at this and says, wait, I have sites outside the US, Graphiant's not an option. This is our initial go live. This is yesterday. As Ali said, the time to spin up a POP is very quick because it's a low footprint, it's a low power consumption. Our early EFT customers, global manufacturers, have sites in really, really, really difficult places. So this is what we went live with. We will very quickly spin up POPs outside of the US. So like I said, before anybody goes, wait, I have locations outside the US, I can't use this. This is a very, very specific point in time. Okay, cool, sorry.
No worries, no worries. I know the sales guy has to make sure people don't run away.
Shut anything down. Yeah. One other niggling detail here is what is the magic to get from Equinix to the actual customer location?
So this is where we are currently looking at internet last mile to start out with, because we looked at the telemetry and said, well, is the internet last mile bad, or is it the transit that's bad? And overwhelmingly, the data says the transit is the worst offender. But the internet last mile, if you are within a certain latency range, and especially if you're going to take the carrier's own network to get to the POP, because you have the peerings with Comcast, Cogent, AT&T, Verizon, everybody, you should see minimal disruption there. So we started with the internet piece, but very quickly the question becomes, what about people who are on MPLS? What about private connectivity? Couldn't you use that? This is where, again, it's early stages for us, and getting an NNI is a very, very long process. But here again, it becomes possible for us to have our cores connected into MPLS NNIs, which means you could be on MPLS and you could still use the MPLS last mile to get to the NNI in that colo to land in this infrastructure and again, offload a huge amount of overhead. This is why I know it sounds a little extreme in terms of how we're pushing the boundaries in terms of transit networking, but this overall benefits service providers immensely because it so much reduces just the crippling overload on the PE devices right now. Like one of the biggest problems in lead time, no one wants MPLS, but even if you were to order MPLS, that lead time, the absurdity of that lead time is because, well, the PE boxes, how much capacity do they have? Do I land them on this PE box? I mean, we've seen customer sites, right, where people have an edge in Miami, but the PE is sitting, well, in Omaha, because that's where they found the port that they were going to land it on. But what? Why? And it's because the capacity is not there on the PE devices because of all the customer config that they're maintaining there. So ideally for us, it's get the internet-based customers here, and then private connectivity becomes a natural progression to say, this is offloading the resource constraint on the PE device, but it allows you to benefit from having all this MPLS infrastructure. I mean, you've already laid down the cables, it's already there. Why can't you use it? No one wants an internet fast lane, but if there is a lane already there, couldn't you make it faster? You know, it's not like we're asking you to build a new road. It's already there. Just start offloading the state on the PE devices. And you're going to free up so much capacity that you're going to be able to grow so much more for the enterprise.
So if you have a customer that, you know, has Verizon or Comcast at their site, you'll just peer with Verizon and Comcast at your local Equinix site.
Yes.
To try to stay on net for that.
Exactly.
For that connection between your device on the edge. Okay, so the second question that I have then is, it seems your special wonderful tagging and identification system, that's going to work great at the true edges, you know, where I have an individual site and I'm just going to send all my traffic to your box so you can do your magic and identify this is going to my SaaS service at this location, and wonderful. How do you do the split out when you're at a larger site like a customer's main data center or main headquarters where you're not the only connection that they're hitting? How do they properly get to you this specially needed tag devices? What magic does the routing master have to jump around to make this happen?
We know that migrating anything, it has to be easy, and if the network operation team hates you, then it will.
Let me stop you. I'm not talking about migrating because we're migrating at the edge. I'm talking about the place where you're never going to migrate. You're always going to have 5 different connections and you're one of the 5.
And this is where in those environments, and like for example, a data center environment, it would be if you wanted to do selective routing in that direction, this is where all the routing techniques that we are well familiar with kick in.
Yeah, I'm asking you, how big a headache are you giving me?
Well, since it's a service, I guess depending on how much of a headache you have that you want me to take care of. I think this is where, in its current form, this would be one of those routing things that's like, all right, do we use a community tag and whatever is in this community goes over there? That's one possible approach. But obviously, we don't really want to have to play routing games long term. This is eventually going to be a case of, couldn't I put that in the application stack itself? But that will be a while before we get to that point, because that will mean, okay, now the app developer itself is just doing that, and the network team is going to feel a little bit unhappy about the fact that the application team can directly put into their encapsulate in the data packet which network path it's going to take. I think that may be an interesting journey we may end up on. I don't see it as avoidable, because people
Have
want
you dealt with application programmers? They're actually going to do this.
It's the fun part, right? Where if they don't think they're doing the network piece, where if they're just in the stack saying, you know, there's a menu of things that it automatically just adds on, right? How many application developers, if they know They're just going to mark everything as DSCP46 if it's leaving the host.
Yeah, and they're going to mark everything for the fast lane regardless.
Exactly. And so this is where I think when it gets to the application stack level, we'll have a different world to deal with and figure out how we do that piece. Because the nature of the fact that people want programmatic access to the network will continue to grow. Now, how do we do that in the best possible way? That is still an open question.
Yeah, and most of these applications, quite frankly, that are important to the enterprises are legacy stuff anyway that was written decades ago.
Exactly.
So it's not being actively developed.
And this is why in the enterprise space, it'll go back to which is the community tag for the prefixes that go into that particular mainframe stack. All right, that's the one that's getting this priority treatment.
Okay, so at these core sites, we'll have to identify these critical applications, just like we do now on a typical Sd-Wan
Yes.
operation, and ship them over to the thing.
Exactly.
So that side of things is pretty much the way we're doing it today.
Exactly. So that for us, the idea was transitioning to start using our service shouldn't be such a massive overhead or a whole new training session around how you're going to move traffic there. We should use existing patterns and practices that we have as we evolve into more capabilities.
Okay, so now shifting back to those edge locations, there's everyone, there's going to be a bunch of them that they want redundancy. So,
yep.
How does redundancy work when we've cut that site over?
So from a redundancy standpoint, again, taking the lessons of SD-WAN in terms of you have multiple last mile connections, so you can have a multitude of internet connections. But then even from a cores standpoint, there's a multitude of core locations that you can access. And this is where, again, because you're not strictly tied to a VPN tunnel, you can very quickly move to a different core location, because as long as the tag is correctly set, the core doesn't maintain a full session state with the edge device. So you can actually move from core to core within sub-seconds if necessary. We're not looking at a whole IPsec whole resetup event.
And that means even if it's asymmetrical, it's still going to work.
That's the best part about this. Now, it makes the SLA piece tricky for us because we have to guarantee SLAs, and the latency variation becomes the thing that we have to plan around and put plus minuses around. But the asymmetry no longer is a problem in terms of traffic session state.
Clever.
Yeah, it's a business problem, not a technical problem.
You talk a little bit about throughput. I mean, you talked about you're targeting a certain size enterprise. Are the branches that are too small, too large? Is there like a Goldilocks branch that you're looking at to start?
So
kind of what is that landscape?
For us, if we look at the bandwidth capacity ranges, we're looking at somewhere like the Goldilocks for us depends on how we classify the size of this, 50 megabit per second going all the way up to 20 gigabit per second is our range. Beyond 20, it starts to become a little harder for us right now, given the state we're in as an early stage company and not having all the capacity in the world.
Can you say that one more time, please?
50 megabit per second to 20 gigabit per second.
You.
Is that a limitation on x86 hardware, or is that a limitation on the data centers you're putting equipment into?
It's the reservation capacity in those data centers.
Okay.
The lead times in those are longest. So if I was to start ordering a whole bunch of 400 gigabit, yeah. And it's expensive, and I don't have infinite money either.
Yeah, you end up getting into their capacity planning and their
Exactly.
build outs
And so for us over the next year or so, that's that range, because we have enough capacity for that already, and we can account for that kind of growth a little bit easier. On the x86 side, we know VPP already delivers massive amounts of throughput. Between everything that Intel's doing, Microsoft that, based on Metaswitch, some of those other things, I mean, right up to 100 gigabit per second on x86 is not even a problem. Our limiter these days isn't even the actual x86, it's more of the NICs. So currently looking at what's happening with Columbiaville and Connerville's generation on Intel, and the smart NICs that are supposed to come out in next year and the year after, that starts to become a little bit interesting for us around what's the 400 gig NIC range and the density for the 400 gig NICs. That's where things become. But then now you're also in like Broadcom and barefoot territory.
Just kind of thinking about speed parity, are there thoughts to go to 40 and 100 gig?
There are. I think for us, there is the progression growth to that. Right now, our Goldilocks is for that reason. Once we go past those bandwidth considerations, we would be a much bigger company with a much heftier capacity purchasing that's happening with all the providers.